I forgot to record this, but it's fine. I'll just start from now. Problem 7 here. Evaluate this. Adam, do you want to give it a try?
Sure. So the first thing, actually I can see already. I think I made a mistake, but so we can simplify the numerator to 5. I'm sorry, to 10 to the -2 over 10 to the -3.
Okay.
Oh, actually, I did do it right. Okay. And then because we're dividing the exponents, we subtract them. So it becomes 10 to the -2 minus parentheses -3.
Great.
And then the parentheses, they become addition. So it becomes 10 to the 1, or yeah.
Okay.
Yeah.
Good.
And then
and it will be 10. Right?
Yeah.
Great. Thank you. You kind of just take 5 to the 0 as 1 here. Let's leave it out as 1 here. Yep. Great. Thank you, Adam. Yep. And it's the correct answer. Let's see. Okay, the next one. This one, expression 1.25 times 10 to the -14 can be written as 2 to the m's reciprocal of 2 to the m 5 to the n. What is the value of m plus n? Well, I don't have a very clear clue of what I'm going to do. So, but I see the question want me to convert this into something with base of 2 and base of 5. So let's see if we can convert this into something with base 2 and base 5. So 1.25, we never play with decimals in our exponents chapter, but what do we do this? Can we convert this into fractions? So we have whole numbers in numerators and denominators. Yes, that would be 125 over 100 is exactly 1.25. So in this, doing this, we have all integers now deal with fractions. That's fine. And we have 10 to the -14 here. And so 125 is 5 to the 3rd. And here 10 to the n squared for 100. And 10 to the 14, -14. And here is 10 squared in denominator. Will be, we still keep the 5 to the 3rd, and then 10 would be the -2 here, right? And then 10 to the 14th here. It's in the denominator. It's in the denominator. If you want to bring the reciprocal, we need to add a negative sign in front of the. Or if you look at this, it will be this, right? And squared 1 over 10 squared is 1 over 10 squared, right? And this would be 10 to the negative 1. The reciprocal of 10 is 1 over 10. And then you have 2 outside. So you still have the 10 to the negative 2. So here we have 5 to the third and the 10 to the negative 16. And we only have 2 and 5 as bases here. So 10 doesn't work. We need to break 10 into 2 and 5 to design something similar to this. So we have 5 to the third, and then 2 times 5 to the negative 16th. And then if we the exponent into the parentheses, we have 2 to the negative 16th, and we have 5 the next negative 16th, but we have 3 here, so it will be negative 13 left, right? And then this will be as the negative law for the negative exponent we just showed at the beginning of the session. I gave up my negative sign here, but you go to your reciprocal. Right? I gave up my negative sign here. Base. You need to become your reciprocal. You need to become your reciprocal. I can give up my negative sign here. So it becomes 2 to the 16th times 5 to the 13th, and whole thing reciprocal. And then we already achieved this form. So we know 2 m is 16, n is 13, but we add them up. So m plus n is 16 plus 13, which is 29. That'll be the answer. Any questions on this? Feel free to ask. This session is for you. Okay, if not, let's go to the next one, which is problem 9. We have 3 problems left. That's good. Let's see, how many digits are in the decimal representation of the product of 2 to the 12th power and 5 to the 7th power? So what is a decimal representation? Decimal representation is just say, for example, 3.5. On the other hand, if it's in the fraction form, it will become 7 over 2, right? These are the same, excuse me, these are the same numbers, but different forms. So this is the decimal representation of 7 over 2. So let's see the product of 2 to the 12th power and 5 to the 7th power. We don't want to multiply them out. Those are huge numbers. We don't really want to multiply them out. But we can, since we're doing a product, let me start from here. Since we're doing a product, we want to design something that we can easily calculate. We know that 2 times 5 is 10. So that will be easy to do any calculation if we can convert 2 and 5 into 10. So at least we have 12 copies of 2 here, and we have 7 copies of 5 here. So we can break 2 up into 5 plus 7, and then 5 to the 7th power. What I'm doing is I'm trying to at the same power for 2 and 5, so I can combine them and make a power of 10 out of them. So I can break the 12 into 5 plus 7, and by the law of exponent, I can have 2 to the 5th times 2 to the 7th, and then 5 to the 7th. And then by the associate property, we can combine these two together. So we have 2 to the 5th, and now we have 10 to the 7th power. And we just talked about 2 to the 5th. That's 32 to 10 to the 7th power. And then having 10 to the 7th power here, we can easily find how many digits are here. This is just 1, and we have 7 zeros behind that. 1, 2, 3, right? 10 to the 7th power. 10 squared is 10. It's 100. We have 2 zeros. And 10 to the 3rd is 1000. We have 3 zeros. 10 to the 7th, we have 7 zeros here. So you have 32 in front. 32 times 1 with 7 zeros will be 32 with 7 zeros. So in total, we'll have how many? 1, 2, 3, 1, 2, 3, 4. Okay. So total we'll have 7 zeros and 3 and 2. There are 2 digits. We have 9 digits in total. And this is already in the decimal representation because the decimal is here. And there's nothing behind the decimal. Everything is 0, so we don't write them down. It's already in the decimal representation. That would be our answer. That's 2 digits for 32 and 7 digits for the zeros. So we have 9 digits. Again, we don't really want to multiply these numbers out because they are huge numbers. There must be some trick we can do to easily calculate numbers out. The trick we're doing is get the same copies of 2 and same copies of 5. We make them copies of 10. So 10 is very easy to count how many digits there are, right, with powers of 10. So that's the trick here. We take this and this into the power of 10. And then what's left here is small enough. There are only 2 digits. And we know 10 to the 7th has 7 zeros. And when it times 32, the 32 will be followed by 7 zeros. We have 9 digits at the end. So the next problem we have, well, it's complicated. We can just step by step following the rules, following the laws of exponents we just learned last time. So in the parentheses, we have 5 to the 5th and to the 5th again. So by A to the B, and then the power of power, we have A, B times C, right? We have 5, the 5 times 5 power, net minus 2, same deal. 5 to the 4 times 6 power. And then whatever we have outside, we can just leave it for now. Then we have 5 to the 25th minus 2 times 5 to the 24th. And then everything, I just put it down here. I'll just put it down here, 5 to the 23rd. Wait a minute, we have a subtraction here. We cannot just combine these two because we have a subtraction here. Remember, first section we learned last time, we can factor out. This one has a factor of 5 to the 24th, right? Because it is 5 times 5 to the 24th. It combines to 5 to the 25th. And this thing obviously has a factor of 5 to the 24th. So we can factor it out. 5 to the 24th, factor it out. We have a 5 left here, right? 5 to the 24th out, have a 5 left. And we have a minus sign here. And we have a 2 left here. Well, that's much easier. And then we have the 5 to the 23rd. Underneath, we can cancel 5 to the 23rd. Same deal. 5 to the 23rd is a factor of this. If you cancel 23 copies out, you will have a 5 left here. Right? There are 24 copies. We canceled 23 copies out of them. So we have 5 left here. We have just 1 left here. And then what we have left is 5 times 5 minus 2, which is 5 times 3, which is 15. Right? So the trick is, at the beginning, we don't have much clue. We just try to simplify it first, so we can easily find what's the real relations between the numbers. So we just simplify them to the powers, and then trick is this is subtraction here. We cannot just cancel out as if it's a multiplication here. So what we can do is factoring out 5 to the 24th, because it's a factor of both terms. We can factor 5 to the 24th out from 5 to the 25th, and also from here as well. And then what's left there is very easy after you cancel out 5 to the 23rd. So that would be the trick of this question, is the factor out. And the last one, this question, at the first look, we don't even have a law for this type of operation here. We always have something's power times something. We never had something's power plus something power. We never had a law to deal with this situation. Fortunately, after observation, we find all of these are the same. We have 3 same numbers. What does that mean? It means if we add something 3 times, it will be 3 times this thing. That's the trick of this question. At the beginning, it looks like we don't have any laws to apply to it, but we found 3 numbers are exactly the same. So if you convert the addition to multiplication, you will get three copies of this number. You will have 3 copies of this number. That's totally valid, right? Just convert addition to multiplication. And then you see this is 3, and this is 3 to the 33rd power, and you multiply them together, it will be 3 to the 34th power. So our answer will be x needs to be 34. And that concludes all of the questions of the problem here. Any questions? And okay, some of you now submit the problems, your answers, your homework for this week. That's totally fine, especially for students who didn't attend the meeting, the class last time. If you find anything challenging, and if you don't, you're not sure if you can get a correct answer, sure you can work out problems you can. And then for the ones you are not sure, try to write down the steps as much as you can. Wherever you lose the clue, you can stop there. At least looking at your steps, I will know where you got stuck, and I can help you maybe. And so I will send these notes to you after the session, so you have something to look at compared to your answers. And thanks everyone to attend today's session, and I'll see you on Saturday. Have a good night.
Bye. Have a great day.
Thank you.